G'day, my name's Steve and this is Reeves's Workshop. Today we're going to carry on finishing the lens frames for the marker lights, and then get back onto the tanks for the Garratt. So this is Garratt part 8. I'm going to make the lens covers now. The lens cover is actually some Perspex. This was CNC routed by one of my suppliers. It's got the white protective plastic on it. So I'm going to leave that on while we do the machining. That's the diagram of it there. So we'll mount our bit of brass in the lathe and start making chips. Once again, I have the job sitting a long way out of the chuck, and I've had to do that as I want to make 4 lens covers, and I really want them all the same diameters, all mirror images of each other's. So I'm going to make 4 sections, so that means I have to be very careful in my machining. So I faced off this surface with a 5 thou or 0.13 millimeter cut. Now I'm machining this one at 10 thou or 0.3 of a mil, and I'm using my power feed as I've got a fair distance to travel. So I'm going to put plenty of lubricant on this and just be careful. Very fine cut, but it reduces the chances of vibration, or even worse, the job coming out of the chuck. So I'll keep going now until I've got it down to the correct diameter. I've polished that up now using 1200 emery paper, and that's because you're going to be able to see the outside of the lens cover when it's on the marker lamp. So I've done a first polish. I'll do a final polish when the machining's finished. Next stage is I want to put a 7/8 of an inch or 22 millimeter hole down the center. So I'm going to center drill it, as you can see I'm about to do here, and then I'm going to start drilling it out with as big a drill as the lathe will allow me to do, and that's going to be a slightly bigger diameter drill than the lathe's designed to use. So once again, it'll be a stepped process where I use different diameter drills, slowly increasing so I don't overload the lathe or damage anything until I get out to the biggest size drill. Then we'll put the boring bar in there and do the final diameter of the hole using the boring bar. So we'll start off with center drilling. I'm going to miss a few of the stepped drilling till we get to the bigger diameters, and then I'll show you how I do that very carefully without overloading the machine. I'm now at the point where I want to start using drills that are larger in diameter than really what the lathe is designed for. So my chuck here has a 3/8 or 10 millimeter drill maximum drill capacity, and so for any of my precision work I never go over 10mm. However, when I'm doing roughing work like this, I can go over diameter, but you'll see I've had to step the back of the drill down so it will fit into this chuck. You'll also see score marks on here and here, and the reason I've got that is I'll also use these drills in my hand drill, and I've got an electric drill with big enough capacity to operate these drills. But the trouble with this design of chuck is they don't have the best of grips, and sometimes just as the drill is starting to break through the material, it'll spin in the chuck, and that's what's caused all this. When I do my precision work, I'll use a keyless chuck. These ones here are built to a higher quality tolerance than this general purpose chuck is, and you don't have the same problem with them. So I have two sets of drills. I have my roughing work drills like this, and then I have my precision drills that I use in the other chuck where it won't spin and get scored. This is the largest size drill I'm going to use today. This is a 21mm or 13/16 drill, so it's just under the 7/8 or 22mm diameter that I want. So the key to using this is I'll slow the lathe speed down. I'll also make sure there's quite a large hole in there to begin with, so this doesn't have to cut a lot of material, and that'll save overloading the bearings or damaging the lathe in any way, while at the same time enabling me to drill a bigger hole. Now we're ready to drill with that big drill bit, so I've made this hole as large as I can to reduce the amount of material that this edge now has to drill out, so that reduces the tool loading on this drill bit. This in turn reduces the loading going this way onto the bearings, and as long as I keep the loading within the capacity of the lathe, I won't damage the lathe. So we'll put on plenty of lubricant. You can see I've got my back gear set up to give me a reduced speed. And now we'll cut the hole. So we're getting a little bit of noise coming from the drill, and it's vibrating a little bit. But you see the speed of the chuck hasn't slowed down. So that means we're not overloading the motor or anything else. I'll keep an even feed going with plenty of lubrication. And you see the way the brass is chipping, so it's cutting cleanly. See that? And I'll drill that all the way through. I'm now ready to bore the hole out. So I need to make sure I get to the correct depth. So you see I've got a dial indicator there, and the needle will go around about 4 times before it reaches the 0, and then I know I'm at the correct depth. So I'm going to take a light cut and bore this out to size. One, two, three, 4. Even at that slow feed rate, you notice I had to react pretty quick because the dial on the dial indicator was whizzing round. So I let it go 3.5 turns, release the saddle, then very carefully held the drive for the saddle to get that last half a turn and then stop. And that way I stopped the boring bar from hitting the end of this. So now we'll check we've got the right diameter using this telescopic gauge. Just use this to hold it steady for me while I measure. If I can get it to hold steady. There we go. And it's reading exactly 875 thou, which is what I want. I have to make a counter bore now. That's 1¼ inches or 31 millimeters in diameter. That is 5/16 or 8 millimeter deep. So I've put the boring bar up against the existing hole as a reference, zeroed my dial, and then I've moved the boring bar out. You can see the recess, little recess there. So I've now marked that, so I can now bore it out by locking my saddle and turning the compound dial, and I'm going to go 300 millimeters, 300 thou I should say, to begin with, and then I can finish it off once I get it to size. I've roughly machined that hole now, so I'll put my telescopic gauge in to check it, and then when I measured it, it came out to be 215. I want actually 230, so now I'm just going to machine the last 15 thou off this. I already know the depth is correct, I trust my machine. So we'll finish that off and try it out. Now I've double checked the depth of the cut, compared it to this. I've got the perspex on there, and I can see, if I put it in the light, that it's just missing the body, so I now know that's the right depth. Double check that fits in there okay, which it does. So we're all good to part the first one off. To part the first one off, I've brought my parting off tool near the job, put the ruler across here, and I gently bring the tool up till it's just touching. And now I know that that's on that surface. It's actually not quite right. Let's fix that. Not yet. Okay, that's it there, so I'll lock that in place. Now I know I need to move this 410 to get it to the right depth, so I'll count that off on my compound slide. 1, 2, 3, 4, 10. I'm going to allow a little bit extra because I want to be able to face that off and make it look nice, so I'll put another 20 foul, and now I can part that off. A little trick you can employ is you can put this bit of brass bar inside here, so once the parting off tool is cut this all the way off, this will fall onto here and it doesn't fall on the ground and you don't damage it. So we'll part it off now. Once again, plenty of lubricant. I always feed in with my left hand as it gives me a better feel for parting off. That way if the tool starts to grip the work, I can back off slightly. There we go. First one done. Now we'll repeat this 3 more times for the others. Now I want to face off this, and I'm going to make sure that the thickness is correct in here. So I've just put the micrometer on here and measuring it. I'm making it 32 thou. So we'll go over to the lathe and start doing that. I've increased the speed of the lathe a little bit to give me a better finish. And in this particular case I only need to take off about 6 thou to get the correct thickness. So we'll do that by facing off. Just face off nice and slow to help put a good finish on it. As it's something you're going to see, I'm going to polish this up with some emery paper and make it look good. This will take a while to do, so I'm not going to show you the whole lot, just give you a bit of an idea of how I'm going about it, and then I'll show you the finished result. There's the end result, nice and shiny, and once you polish it with Brasso it comes up pretty good. So I'll just grab one of the windows. I can take the cover off it now. Just be a bit careful as I've got dirty fingers. Fits nicely. Lastly, I'm going to hold the lens cover with a 10BA screw so it doesn't fall out, and I'm going to put that at the base, which you'll see. So first thing I need to do is mark out the hole. So I've just put a spacer on here to get everything the same. Use my center punch. Next we'll move it to here. Give myself a little bit of light so I can see. And I can very carefully drill that hole. And deburr it. I'm going to put the hole at the bottom here so that when it's standing up like this you won't see them. To do that, I've found the center of the body, line the hole up with the center there. Probably better if I showed it that way. And now I can very lightly center pop that. You can see it there, and I can drill it. So I've got the tapping drill set up here, so I'm going to tap for the 10BA thread. I'm going to tap a 10BA thread now. A couple of tips for you to help you not break your tap. I buy tap wrenches like this design, where it has a square hole in the jaws to match the square ends of the tap. Then I use an arbor like that, and you'll see a little homemade one I've made for this particular one to hold it in the chuck. So now that's perfectly in line, so the tendency for it to go back and forth like this and snap off is much reduced. Next thing, even though I've got brass, I'll put some lubrication on it. I don't use the handle, I actually tap with my fingers. That way I can feel the tap cutting the material. If it starts to bind or go stiff, you can back off. You should be backing off regularly anyway, but it's another way of stopping you from breaking the tap. And then the last thing I do is I drill the hole all the way through here. I don't tap into what's called a blind hole. That way, as the little chips are coming off, they'll fall down out of the way and keep the tap clear. And by doing these things, you'll be surprised on just how smaller threads you can safely tap without breaking. A little bit of care and a little bit of patience gets you there. I can feel it starting to break through the other end. It was coming out of the arbor, so I just moved the drill down, locked it in place. To stop it wobbling. I can feel it's just broken through and now it's going through the other end there. Once again, when you're taking the tap out, be very careful. Just make sure you don't snap it. Any sign of resistance, stop immediately, go the opposite direction to clear it, and then keep going until you've got it out. The next thing I want to do is make a 10BA bolt that's about that long. And I need to be able to hold it in the lathe and machine the end of it. So what I do is I screw it into this holder here, and this is how it's made. So it's this long for the jaws of the chuck to grip on, but because it's only this long, I've recessed the hole. You can see the threaded section here, and that's what I've screwed it into. Now all I've got to do is cut that off, mount it in the lathe and machine the end. And here we have the finished bolt cut to length. And I've already done one already, and you can see it's screwed in, holding this on. And it's all done. So now we have a marker light all finished on the outside. All I have to do now is the wiring needed to light it up, but we're going to go back onto the water tanks now, and we'll do this later on. The last few videos have been a bit longer than normal. There's so much to show you that it's difficult to edit it down to about 20 minutes, but hopefully it's been of help to you. See you next time.